Wait! We should be in maths!
We've moved.
We have moved.
This isn't the hall.
There's no weird year 10s and curtains. Teachers.
What's happened?
I think we're in a house.
We're in a house. We had to say goodbye to our board.
We did.
Unfortunately, at the school.
And to the school. We had to say bye to school and the board. So we asked Mr. Soldier if we could take it, and he said,
No.
no.
I mean, he said you could put bids on it, and then that was a lie. You can't. And they're all going off to academies. But they accidentally threw it in the skip.
They did. So we nicked it. It's ours now.
This is actually it. This is the one from
it's-
in the hall. We took
It's
it.
got a few extra scratches. They dented it a bit and stuff, but
Which is why it was in the skip.
yeah, we consoled it. It's better now. And now we're bored.
New board, new topic. We're on core 2.
We are on Core 2. It's a new, very nice book. Oh, it's got colours, very pretty. Core 2, like Core 1. Bit more bonkers, you get a calculator.
Yes, you actually get to use a calculator.
Lots of graphs. Goodness, lots of graphs and stuff. And first,
Indices.
indices.
So
Yeah.
let's swap places.
Alright.
We're going to go through the rules of indices first. So if we have x to the power of a times x to the power of b, what does that equal, Triv?
Oh, well, just grab a board pen. And that equals x to the power of a plus b.
So if this was 2 cubed times 2 squared, it would be 2
To the power of 5.
5. Yeah.
Yeah.
Similarly, x
X to the a divided x to the b. It's not a surprise, it's not a crazy thing. As you expect, it would be x to the a minus b.
and that should be revision for GCSE. Or
Should
this
be.
should
Yeah, it's a bit more complicated, might be a bit rusty on it, but this is more or less
have x to the
what
a
you did before.
to the b.
No,
That's a bit different.
it's a bit different.
That's not quite like this.
No, that becomes x actually to the ab this
To
time.
the ab, this power times by this power.
Yeah.
X to the 0
And this
is
is rule you should know from GCSE. Anything that's power of 0 is 1.
anything.
Anything.
And the last one, x to the negative a is 1 over x to the a.
Yeah. You just sort of flip it.
And these are the rules of indices, which is the unit 1 of our core 2 over there.
Yeah. So Wayne, what if this x was a y and it was a different number?
Well, there's no real shortcut for that. Let's put an actual number example, it's hard to talk about it algebraically. If we had 2 squared times, and this was a different number, this wasn't 2, this was 3 cubed or something. There's no shortcut for this, you're going to have to do 2 squared and then times it by 3 cubed. And that's
Okay.
that really, it's as simple as that.
Yeah.
Now let's use these, not on the easy examples that are in the
No.
book, we're going to go straight on
More complicated.
about 2 pages to some more complicated ones.
Yeah. It's like the ones you might get in the exam
Yeah.
early on. They're quite easy.
Quite easy. Easy
Few
marks,
marks.
the whole thing.
Yeah.
You've got to know these
Just
rules.
use your rules and you're done.
Let's go through a few examples then.
Alright. Let's rub this off. And now, example time.
So
Right,
these are examples that are in the book. They're a bit trickier than the ones before.
They're
You
a
skip
bit
them.
trickier, but there's a few tricks you can use for these trickier examples.
Yes.
You can remember, like this one.
64 to the third. What does that mean, Trip?
Well, it really means 64 to the cubed root
Yes. Cubed root.
of 64.
So something times itself once times itself again will equal 64.
Yeah.
And you should know that that's 4.
You should know that's 4. 4 times 4 is 16, times 4 is 64. Yeah.
It gets a little bit trickier when there's a number on the top and a number on the bottom.
It does.
But don't panic too much.
It sort of means you have to do two things.
In fact, if we write this out, we write at this stage here, this means the cubed root of 64. So if we write that out here,
Yeah.
it would be the square root of 16, but then we do something special with the 3.
We do.
That whole thing is then in brackets, and it's cubed, that's what the 3 on the top means.
Yeah, so you sort of
You
do
can
two
do
things
that
once.
for this, you can put that in brackets and do it to the 1, but that's just the same
But it's
thing.
the same thing, so that's silly. So if we do the cube first, no, the square root first, so that'll equal 4 cubed. And that equals
Just done is
64, so it's doing it backwards.
But that's what it means when there's a number on the top and on the bottom. Bit trickier.
Yeah. Then we have a minus.
That makes it even trickier. Minus
It
number on the
does.
top and the bottom.
So if we do this first step,
From your indices rules we've just done, you should know that minus equals 1 over.
yeah, so we do that first. So we 1 over 32, ooh, I'm writing wonky, to the 2/5.
Now this goes on to the next bit. You've got 1 over. We've just said what this means. It means the 5th root of 32
Yeah. All
all
squared.
squared. Which we then go on to the next bit. The 5th root of 32 is 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32.
Yeah.
So we've got 1 over.
1 over 2 squared, which is 4. So that means it's just a quarter. It's quite nice.
Got a neat one.
Now this one's bonkers.
This one's a little bit harder than the others. Again,
So you have the minus first. Should we do that first?
yeah, we'll do that first.
Okay.
Minus means 1 over from your
So
rules.
you have 1 over. Big thing.
27 over 64,
And all of that.
all of that, to 2/3. Now what does that mean, Triv?
Well, that means you have to cube root all of that and square all of that. So here at 27 over 64, the square root sign, little 3 on it. Yeah. So which one are we going to do first? Should we do the cube root
I
first?
think we should do the cube root first.
Okay, so
Now, if you remember from back in Core 1 we did surds and we did the
We did do
rules of
surds.
surds, well that could apply here. The cubed root of 27 over 64 is the same as the cubed root of 27 over the cubed root of 64.
yeah.
So I'll write this one more time before we actually do the maths. So you've got the cubed root of 27 over the
Cube root of 64. Makes it look a bit nicer, easier to deal with. So we did the cube root of 27. What times by something times something again is that? It's 3.
3
3 times 3 is 9, times 3 is 27.
over, we did the cubed root of 64
Here, over here, here it's 4,
4
and all of that squared. We square it, square
It's
both
quite
sides.
easy, it's quite easy to square. When a square just means times by itself, and you should know from GCSE that you times a fraction by a fraction,
You
the
just
top
times-
numbers times,
times,
the top numbers
yeah.
times.
So 3 times 3 is 9, 4 times 4
9.
16.
Over 16. 1 over 9 over 16
It's the same as
is the
6,
same as
16 over 9. You flip it to get rid of the 1 over. And that gives us our answer, which isn't that nice either, really. But this is the sort of question you're more likely to get in the exam. The last one we did.
It's quite a tricky one.
It's quite a tricky one. Use all your rules there.
So Core 1, don't forget it. It comes up even in Core 2.
It does.
Even
It's
though
more
Core 2 is
used.
harder.
And you can use a calculator, so if you struggle to do the sort of thing like cube root or something in your head, you've got a calculator for that.
Yes, it will ask you, or it might not ask you, but the marks will be there for showing your work.
Yes,
So
you need to
can't
show
just
your work, you
plonk
can't just
this
put your answer down.
But
These are the
that's
steps.
how you do it.
Yeah.
Now we're going to go on to something exactly like this, but slightly different.
Slightly different.
It's got X's in it, which makes the
Ooh.
whole thing a little bit harder.
Oh dear.
Not to
Crack
panic.
Hello,
We're back
we are back.
with X's.
Ooh, a bit more algebraic, scary stuff.
Yep.
We're going to start on the top left, we're going to do a pattern here.
So we have X to the power of 2 over 3 equals 25.
Now, our last video we sort of explained how to make this a bit simpler, so our first step, should we do that?
Yes.
Yeah.
So you write it in a simpler form to what it is in. So I would write it what that actually means as a power. So the cubed root of x squared, which is what the 2 over 3 actually means, is a simpler way of writing it,
And that
equals
will equal
25.
So, like a normal equation, start doing stuff to both sides.
Yeah, so we've got to square root both sides to get rid of that squared,
Yeah.
leaving you with the cubed root of x equals, and then the cubed root, squared root of 25, which is 5.
It is 5. I was just going to write 5.
And then you've got to cube each side to get rid of the cubed root.
Yeah.
So that will leave you x on that
equal
side, and 25 cubed, which is 125.
5 cubed.
5 cubed, what did I say?
25 cubed.
I meant 5 cubed, equals 125.
Yeah.
So then you've worked out what x is. It's sort of what you do in all the questions is to write them in a better form than what's in the question. That's not how you would start.
Yeah.
Second example.
Second example.
Bit
Do you remember this
scary.
one, Wayne?
I'll type it. So we've got 9 to the x equals 1 over 27.
That's when we start doing clever things.
Because x isn't a number like in this type, well it is, but it's an indice number, which
Yeah.
is...
We quite like to make the equation equal x, but it's an indice. So how do we do that, Wayne?
Well, what you've got to do is you've got to get the left side and the right side of the equation to be something to some powers, and
Yeah.
you should be able to see that 3 to powers would work on both sides.
It would. So you get all the powers out. So 9 is actually 3 squared
to the x.
x, and that will equal 1 over 3 cubed.
Yes.
Yes.
Sorry, I'm with you now.
Yeah.
1 over 3 cubed.
Right.
Now by our rules that we did right at the start, 3 squared to the x is the same as 3 to the 2x.
Yeah.
And now 1 over 3 cubed,
Same as 1 over minus 3.
3 to the minus 3.
Now we do something clever.
We do something clever.
Start making an equation with this bit.
So we can just ignore these bits
Yeah,
now.
because they're the same.
3.
We're going to sort of get rid of them.
2x
Sort of. 2x equals minus 3. Which
So
means x must equal.
minus 3 over 2.
So that's that.
That is that. But now that's formulating an equation with the indices. We've got another example here that's actually a lot harder.
It is quite a lot harder.
It's a bit of a bugger. I think we're going to get rid of the blue pen first.
Yeah. So,
Again, we
with
start in the
four.
same way.
Yeah. Turn all these into the same power. There's 2's already. Can't go much lower than 2, so you should change this into a 2.
Yes, so 16 is equal to 2 to the power of 4.
Yeah.
2 to the 4 in brackets to the x times by 2 to the x minus 1. That can't be simplified because it's already at 2. Equals 2 times
Oh, I'm writing 1.
2 times, and root 2 is just 2 to the power of a half.
It is.
Right, now we've broken everything down like we did here, but a bit more complex. Now we use our, again back to the first of the part of this video, we use our rules.
We use our, yeah, use our rules.
2 to the 4 to the x
So
is 2 to the 4x. Times by, again we'll just leave that as it is, 2 to the x minus 1.
Yeah.
Equals, and we can simplify, this is 2 to the 1 times 2 to the half. So you add them,
Those
if you
together.
remember, x to the a
And
times
1
x
is
to
2 over 2, so that means
2
to the 3.
3 over 2. Now if we simplify this time, you've got times again, so you just plus in the powers, because it's both 2 to the power. So you get 2 to the 4x, 2 plus the x minus 1.
So that ends up being
2
2
to the 5x minus 1.
minus 1 equals.
2 to the 3 over 2.
This is when we can do our thing.
This is where we can do our thing again, like the 3's cancel, the 2's cancel. So we have 5x minus 1 equals 3 over 2.
Like a normal equation, add 1 to both sides.
Add 1 to both sides, so 5x equals 5 over 2.
And that means 5 both sides by 5, x equals
5 over 2 over 5. It's just 5 over 5, but it's just a half.
And that gives us our answer.
just like this. You've got to get everything in its sort of an easier format, so we can get it all in the same number.
Yeah.
And you just simplify it down. It's a bit hefty.
It's
and
quite a lot of
you
steps.
can make a lot of mistakes here, so just be careful.
But it is quite mark heavy because of a lot of steps.
Yes, and you can't just type that into your calculator and let it work out X.
Yeah.
You've got to actually do it. So it's worth a few marks, worth knowing.
Yeah.
I think you should probably go on to a test yourself now.
I think we should do an exam question, yeah.
Yeah.
Let's do it.
Let's do it. Okay. So,
Exam time.
Test yourself. Page 15, question 10 of this book.
This book, very nice. Alright, let's do it. We'll do the first one. So, here we go. Question 10, part A, I. Write each of the following as a power of 3. The first one is 1 over 27.
1 over 27.
I did both. The second one is 9 to the power of x.
Right. Do you have a red pen?
I do.
Oh, excellent.
Alright, that's wrong. So
Now,
Wayne's going to do it.
Triff will talk you through it.
I'll talk you through it. So we should know that as a power of 3, 1 over 27 is 1 over 3 cubed. And from our rules, the 1 over, we can get rid of that, put minus sign. It's very easy, quite a quick question. Done. Now, round 2, 9 power of x. A bit more tricky, I guess. So we write 9 to the power of 3, 3 cubed, 3 squared to a close bracket. Sort that out, which means 3 to the power of 2x. And then, yeah.
Quite simple questions, probably only worth a mark, perhaps 2 for this one maybe, but not hard questions.
They're
but
not hard
could
questions.
come up in the
It
exam.
could come up.
Can I have the book?
Yep, a little bit of a swap.
Can I have a pen?
I have a black pen as well.
A black pen? Oh
Yeah.
goodness, I put it down. Here you go.
Yes.
So, 10b, hence solve the equation 9 to the x
Oh, hence, yes.
times 3 to the power of 1 minus x equals 1 over 27.
Okay. I should remember.
And
Hence.
it says the expresses a power of 3 again. So.
Okay. So it says hence, that means you use these things. And from our thing we did before, we know we had to get in both all the power of 3 anyway.
Yes.
So let's do it. So use this
So you
one.
can just pretty much nab my answers at the start. 9 to the x we've already done, which is 3 to the 2x.
I'll change pen.
Oh, I'll take this.
Okay.
So you can nab my answers. 9 to the x equals 3 to the 2x, we've just done it. Times 3 to the 1 minus x, can't really be simplified. Well, it can't be simplified at the minute. Equals 1 over 27, again we've just done, is 3 to the minus 3. Now from our rules at the beginning, x to the a times x to the b is x to the a plus b, so you add 2x to 1 minus x. So you're going to get 1 plus x, 3 to the 1 plus x, equals 3 to the minus 3. And then the 3's disappear, you don't need them. It's 1 plus x equals minus 3. And then like any normal equation, you take 1 from each side, you've got x equals minus 4. Now that could be worth up to 3 marks in a question. But as you see, it's not that harder because it said hence, so you've already actually done the easy bit.
Done that bit.
It's just simply using the rules and simplifying it down.
Done.
Done.
Alright, I think that's all indices sorted.
Yeah, we've done it all.
Alright.
2 indices. Let's have a little chat, and that'll be it.
Yeah.
Alright, so
Yeah.
so we've done Core 2, Unit 1.
We have very small unit this one.
Yeah, very quick video, very
Yeah.
nice.
Try this.
We nabbed the board, that's the,
We did.
that's the most important
That
thing.
was yeah, made our life.
So happy when I saw that in the skip.
Yeah.
Really happy. So, Unit 1 of Core 2, Indices, what do you think?
It was alright, wasn't it?
Alright.
It's not too complicated. A few rules you've got to remember.
X to the a times x to the b equals x to the a plus b.
X to the a divided by x to the b, x to the a minus b.
X to the a to the power of b is x to the a times b, so x to the ab.
Yeah, and x to the minus a is the same as
X
1
1 over x to
x
the
a.
a.
Yeah.
And anything to the power of 0 is 1.
Yeah.
That,
It
that
didn't
rarely comes up in
It doesn't
exams,
come up very often, no.
but it might do.
It might
for
do.
a mark or something.
Yeah.
Did a few harder examples when it's
We did.
like 3 over 2 and minus 5 over 2.
Yeah, you just got to split it up.
Yeah,
Like rules.
it's not too hard. If it's
Not too hard.
x to the power of 5 over 2 is just square root of x
X.
to the 5. And if it's minus, it's just 1 over that.
Yeah.
It's not too horrific.
Not too horrific. We started using when the x was actually an indice.
Yes, and then you formulate your own equation
Yeah.
with indices, which is really cool.
Which is quite cool. I quite like that.
Yeah.
Oh,
That's probably new. You doubt you've done that
No,
at GCSE.
that's not a GCSE thing.
Unless you had a mad teacher who went off topic.
Like the early units in Core 1, it's just sort of a building block and it'll be used a lot later on.
Yes, so you get this nailed into your head like you did with your Y because MX plus C rules and stuff.
Yeah.
It builds up, but it's not a big unit. We're done.
Alright,
This is Wayne Lack and James Trevette.
let's crack on.